Okay, so this is scientific notation, powers of 10. All right, little quick review of scientific notation. First of all, it's used for very big, very small numbers. That way you don't have to count a bunch of zeros and mess up counting zeros. You can tell how far you need to go by the exponent. Okay, so remember with scientific notation, the first number has to be between 1 and 10, not including 10, so really 1 to 9, times 10 to the something. For instance, 3 times 10 to the 4th, or 2.6 times 10 to the negative 3rd. All right. So, first thing to remember, large numbers. In other words, numbers bigger than 1. We're going to use positive exponents. Okay? So, we have an example right here. Pretty big number. It's definitely bigger than 1. We know it's going to be a positive exponent. So, first, to find the number between 1 and 10, we're going to look through and see where we need to put the decimal in order to create a number that's between 1 and 10. So, we need to put the decimal right there, creating 9.35. We already know it's going to be a positive exponent. We just have to figure out what it is. So, we say it's going to go here. So, let's count from there all the way over to the end here. That'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9.35 times 10 to the 9th. Here we go, 3.025 times 10 to the 9th. That's going to be a pretty big number. It says to put it in standard form, so with all the zeros, expand it out. So we have 3.025 times 10 to the 9th. So that means we're going to take our decimal and move it 9 places to the right to create an incredibly large number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would end up here. Go back and fill in the valleys with your zeros. Don't leave it like that because that's messy. Rewrite it. 3, 0, 2, 5, and 1, 2, 3, 4, 5, 6 zeros. Let's put in our little commas. There's the number, expanded form. All right. Small numbers. Small numbers, numbers between 0 and 1, are going to use negative exponents. So if it's a number between 0 and 1, you know you're going to have a negative exponent. For instance, 0.000468. So first, let's create a number between 1 and 10. If you said to put the decimal here, you would be right. Right here. So that's 4.68, a number between 1 and 10. So times 10 to the, well, we already know it's negative because it's a small number. Let's count and see how many it is here. 1, 2, 3, 4. Done. Next one. We've got a number here, 1.0025 times 10 to the negative 5th. So I know it's going to be a real small number. So I already know, move that decimal to the left to make a smaller number. I'm going to move it left 5 times. So I've got 1.0025. I know I need a small number because the negative 5, so I'm going to move left. 1, 2, 3, 4, 5. Fill in the valleys. That would give us 0.0001025. An incredibly small number. All right. So are these in scientific? If not, rewrite them. First one. Scientific? No. The first number is not between 1 and 10. So we know we need to move the decimal right there to create a number between 1 and 10. So that would be 4.265 times 10 to the, let's figure this out. since we're going to decrease this by a factor of 10, right now it's 42.65. We're going to make it 4.265. So because we divided it by 10, we don't have the same number anymore. So since we divided this guy by 10, to keep it the same, we need to multiply this guy by 10 to compensate the factor of 10 that we lost here. So we divide this one by 10, but we multiply this one by 10. In other words, this guy gets smaller, this guy has to get bigger to compensate. So multiply him by another factor of 10, the 4 would become a 5. Let's try another one. Let's try this 150.003. Okay, that's definitely not scientific notation. It's not between 1 and 10. So if you said to move the decimal here, you would be right. That's 1.5003 times 10 to the, well, let's see, 150. We're going to go from 150 to 1.5. So we make this guy smaller by a factor of 100. That means we need to increase this one by a factor of 100. So we're basically going to multiply him by 10 squared. So this one decreased by 100, or a factor of 100. This one multiplied by a factor of 100. So if I've got -6, but now I've got 2 more factors of 10, this is going to become 2 bigger. So now it's 10 to the -4th. Let's try another one. Definitely not scientific notation. This guy is not between 1 and 10. So we know we need to put the decimal right there. So from there to there, it's going to go from 0.001 to 1.29. So it's going to get bigger. So since he's going to get bigger, this guy needs to get smaller. So we're moving this guy 1, 2, 3 to the right. So since we move this guy 3 to the right, this guy basically needs to move 3 to the left. In other words, decrease by a factor of 1,000. Okay. So our new number is 1.29. That's 1,000 times bigger than our original. That's why this guy needs to be 1,000 times smaller. So instead of 10 to the 18th, it'll become 10 to the 15th. All right, one more. We know the decimal needs to go here. So he's going to go from 0.056 to 5.6. So we have 5.6. So he moved 2 to the right. So this guy needs to be decreased by a factor of 10 squared. So since this guy got bigger, this guy's going to get smaller to compensate, to keep the number the same. So he's -9 now. He's going to go 2 smaller. So that'll become 10 to the -11th. All right. Here's a few more examples compensating. So do these on your own, pause the video, and then check them. So this guy would become 2.35. He got smaller compared to this guy. So I moved him 1 to the left. So he got decreased by a factor of 10. So this guy needs to get increased by a factor of 10. So he needs to go 1 bigger. So instead of 10 cubed, he'll be 10 to the 4th. This guy would become 3.1. He gets bigger from 0.31. So since he gets increased by a factor of 10, this guy needs to be decreased by a factor of 10. So 10 to the -5th becomes 10 to the -6. Last one. All ready, scientific notation. All right. Order the following from least to greatest. So what you want to do here is put them all in scientific notation and then compare them. They're very easy to compare if they're in scientific notation. So let's put them in scientific and compare. He would be 5.2. So he gets increased by a factor of 100. So the other guy must be decreased by a factor of 100. So that'll become 10 to the 5th. This guy, 5.12. It's already scientific. Good for us. This guy, he'll become 5.32. In other words, he gets decreased by a factor of 10. So this guy needs to get increased by a factor of 10. So he'll become 10 squared. This guy, we know it needs to be 5.34. Well, that's really times 10 to the 0th, because it's times 1. So if we're going to decrease this guy by a factor of 100 to put the decimal here, this guy needs to be increased by a factor of 100. Which makes sense. 5.34 times 100 would give you 534. All right. If I ask you to multiply, put your final answer in scientific notation. You're going to group these guys. So 7 times 4.5 would give you 31.5 times 10 to the 5th. But it's not scientific. So the first number, 31.5, would become 3.15. So he got smaller by a factor of 10. So this guy needs to get bigger by a factor of 10. So instead of 10 to the 5th, 10 to the 6th. Okay. All right.